Hello and thank you for tuning in. My name is Michael Alfonso. I'm a senior at Florida International University majoring in information technology. I would like to take this moment and discuss the good and ugly of reverse engineering of software products. Now, many of you may be asking, what is reverse engineering? Well, if you guessed it, means engineering in reverse, then you're almost right. Reverse engineering is the process of analyzing an object in full detail and replicating the function of its process. For example, a device was just launched by a company A that allows us to project 3D images after scanning them via a computer. Now, some genius working from his basement decides to sketch out this design and break down the engineering behind such apparatus in such a way that he has made the same product launched by company A on his own. Now, I know that many of you may be thinking, it's an infringement of copyrights. Indeed, it is a copy of someone else's innovation, but one may argue that it is actually a recreation using a different method. The same applies to reverse engineering of software products. It is seen as going backwards through the development cycle. This means one must disassemble, examine, and carefully analyze software that has already been created. Thus, reverse engineering is an examination of the software. No actual software is altered. So I know the term examination seems ambiguous, so let me introduce you about how to approach reverse engineering. To begin, we must determine whether or not the source code is readily available. The first type, white box analysis, involves analyzing and understanding of the source code. There are two types of white box analysis: one that requires source code and those that use binary code. If binary code is available, one can decompile binary code in order to get the source code. Once you're working with the source code, we can study it. Studying the source code allows us to find programming errors and implementation errors in software. There are platforms available to facilitate white box analysis, such as SourceScope and IdaPro. Now that we talked about reverse engineering using code, I will be explaining to you the methods used when there is no code available. This is called black box analysis. This method is used when analyzing a running program by probing it with various inputs. With no code necessary for alteration, one can supply many distant inputs into the program. An example of this type of input would be a malignant one that would ultimately cause the program to break. Thus, we have found a security problem in the code. Considering this method does not require binary code, one can test the program remotely over a network. All that is required is a program running that accepts input. And by inputs being made, we can analyze how a program works and any potential flaws. With this said, it is much easier to accomplish black box analysis than white box analysis. However, white box analysis is more effective in obtaining knowledge of the code and its behavior. Despite all the work one might put into reverse engineering, we must come to terms with the fact that reverse engineering is a very delicate practice that may be subject to copyright infringement. One must use these processes at their own risk, aware that they might stir some legal controversy. At this point, you may be wondering, how on earth does reverse engineering fall into ethical versus unethical practices? The ethical use of reverse engineering are endless and offer a positive outcome for future software and user satisfaction. First, product security analysis. Like I explained earlier with black box analysis, we can identify potential threats that may be hidden in products. Who wouldn't want to know if their new email software has flaws and can possibly expose meaningful data and financial information? Next, interoperability. What's interoperability? It's something that you and I use every day. In fact, I'm using it right now. Using Microsoft products on a MacBook seemed far-fetched idea in the 80s, not anymore. We depend on different computer systems. These systems need to be able to interface. Without reverse engineering software products, this wouldn't be possible. So shout out to the reverse engineer who made this video possible. Next on the list is bug fixing. And no, not those termites that are eating away your wooden patio. I'm talking that software bug, the error, flaw, failure in a computer program or system that produces an incorrect result and ultimately causes your software to fail. You and I have been there. The point when you're browsing and your browser just doesn't support a page and it just crashes. Sometimes software is no longer supported by its creators. Others may try to come in and fix it. It's safe to say that there are many positives for reverse engineering, specifically for software modernization. Reverse engineering allows the developer to understand what is really going on with the current software. They can now analyze flaws and are able to modify imperfections. They are able to build upon the software that is already created in order to make new tools and develop further new innovations. Least but not least, the final ethical take on reverse engineering is taken from an academic standpoint. As an IT student, reverse engineering is a very efficient learning tool. Students need to be able to understand the underlying operations of software. They must be able to understand the blueprint of systems in order to be able to completely grasp and apply new techniques to working ones. So at this point, you all must be thinking reverse engineering is a gift from the computer gods themselves. Unfortunately, that's not the only side to this process. Like a delicious and satisfying Thanksgiving meal, there's always a mess one must clean up. The flaws of having such an advantageous process like reverse engineering can bear potential threats to us and both future program developers. Now, as a company producing the latest softwares, reverse engineering is a serious threat to their innovations. One can use reverse engineering as a competitive technical advantage. That is, obtaining the intelligence needed to keep up with the designs of the latest tech advances. By using reverse engineering, one can understand what competitors are actually doing behind their computers. Ultimately, a understanding of your computer's efficient workflow could cause you to become a better competitor in a market. Additionally, by using reverse engineering, one may gain an edge on an enemy by capturing and dismantling a piece of technology. In fact, this was the case for our U.S. military. Iran tricked a U.S. spy drone into landing by cutting its communication links and reconfiguring its GPS coordinates to land in Iran. That, my friends, is black box analysis being used for malignant purposes. So there you have it. The good and the bad outcomes of reverse engineering. Whether you wish to use such a technique for learning purposes or a competitive advantage is up to you. Comment on your opinions. We will be using reverse engineering. Will you be using reverse engineering?